Welcome to The Explainer. Today we are talking about a really cool new release from Meta called the Code World Model, or CWM for short. And this is all about trying to teach AI not just to write code, but to actually understand it.
So let's start with a scenario that you've probably been there if you're a developer. You ask an AI to whip up some code. It comes back and it looks absolutely perfect. The syntax is clean, the structure is great, but then you go to run it, and something's off. There's a sneaky little bug hiding in there that's all about logic, not lux.
And that exact feeling, the code looks right, but it acts wrong, that gets us right to the heart of the problem here. It's all about the massive difference between syntax and semantics. See, most AI models today are absolute masters of syntax. You train them on trillions of lines of code, and they get really, really good at knowing the grammar, the structure, what code is supposed to look like. But what they often completely miss is the semantics, the logic, the meaning, what that code is actually going to do step by step when it's executed.
And this is precisely the gap that Meta's new model is trying to fill. The whole idea is to move AI from just mimicking the appearance of code to truly understanding the consequences of it. And the secret to doing that is an approach called a world model.
So what on earth is a world model? Well, instead of just memorizing what patterns look like, a world model is trained to build an internal, mental simulation of how a system actually works. In this case, that system is an entire computational universe. The AI is learning the fundamental rules, the physics, if you will, of how code runs.
Here's a great way to think about it. A standard AI model is like someone who's memorized 1,000 recipes. They can follow the instructions perfectly. But a world model? That's like a chef who understands the chemistry of cooking. They know why adding heat makes something crispy, or why lemon juice curdles milk. They understand the cause and effect behind it all.
Okay, so this sounds amazing, but how do you actually train an AI to think like a chef instead of just a recipe follower? Well, the process has a pretty familiar structure, but with one brand new, game-changing step right in the middle.
So it's a three-stage process. First, you've got your standard pre-training. The model just reads a huge amount of static code. But then, and this is the key innovation, comes this mid-training phase. Here, the model isn't just reading code. It's watching 5 trillion tokens of code as it actually executes. Then finally, it's fine-tuned to get even better at solving problems.
That mid-training stage is really where the magic happens. The model is shown what are called execution traces. Just imagine watching a program run in super slow motion. The AI gets to see line by line exactly how every variable changes, how memory is affected. It's learning cause and effect at the most fundamental level.
All right, so the theory is fantastic. I mean, it makes perfect sense to teach an AI what code does instead of just what it looks like. But, the big question is always, does it actually work in the real world? So the model that Meta has released for researchers to play with is a 32 billion parameter model. Now, that number sounds huge, I know, but in the world of today's AI giants, that's actually kind of small. And you really need to keep that context in mind for what comes next. Because the results are, well, they're pretty incredible. On really tough benchmarks like SWE-Bench, which is designed to test real-world software engineering tasks, CWM performs amazingly well, especially when you compare it to other models in its weight class. It is absolutely punching above its weight.
And this, right here, is the big takeaway. The success of CWM suggests that the future of powerful AI might not just be about scaling up bigger and bigger. Maybe a smarter, more efficient path is to train models that have a much deeper, more fundamental understanding of the world they operate in.
So where is this all heading? Well, this deeper understanding of how code actually executes, it unlocks some truly transformative potential, especially when we start talking about AI agents. For starters, think about this. Because the model can basically simulate what code is going to do, it can act as a kind of neural debugger. It can look at a piece of code and anticipate errors, predict what variables will do, and reason about the consequences, all before a single line is ever run. And that leads to the ultimate goal here, a new kind of AI agent that's way smarter and more reliable. An agent that can actually plan and reason about its actions instead of just using brute force trial and error. Imagine an AI you can trust to reliably fix bugs or add new features to a huge complex codebase. And, this whole world model idea, it's not just for coding. This could be the blueprint for all sorts of specialized agents in the future. So when you boil it all down, by shifting the focus from syntax to semantics, from looks to logic, models like CWM are doing more than just getting better at coding. They're taking this small but really significant step towards understanding cause and effect itself. And that leaves us with a pretty provocative final thought. If we can teach an AI the rules of its own universe, is this the first real step toward building an AI that truly understands ours?